So, hello everyone, I'm Christos. There is no lunch for you, there is a presentation for you. Sorry for that. So I'm going to present complementing OSM cycling data through official datasets. So the general structure of the presentation is the extraction of cycling infrastructure data in a standardized format from OpenStreetMaps, then from the official datasets, and then I'm going to present the development of a methodology for comparing these datasets from the OSM network and the official network. And then I'm going to present the results of the dataset analysis and the comparison results. And I'm also going to show the use case of the Eurovelo network, which is the European cycling network, and also what are the next steps after this presentation. So the first step is to extract the cycling infrastructure data from the OpenStreetMaps in a standardized format. So the cycling infrastructure types that we extract is the cycle tracks, the cycle and pedestrian tracks, the cycle lanes, the bus and cycle lanes, the cycle streets, the 30 km/h roads, and the specific service roads, and also the contraflow cycling. Okay. But let's see what exactly is everything. After the name, it is the official definition of every different infrastructure type. But in order to help you, the cycle tract is a segregated part of the road where only cyclists can ride. Then we have the cycle and pedestrian track, where we have also the cyclists and the pedestrians together. Then we have the cycling track and the cycle and pedestrian tracks are physically segregated. Then we have the cycle lanes where it's also segregated, but it's not physical. It's only with lane markings on a part of the road. Then we have the bus and cycle lane, which is the same with the cycle lanes, but is together with, and it is shared with buses. Then we have the cycle streets, which is used also for motorized traffic, but priority is given to the cyclists. Then we have the 30 km/h roads, which is on the local and the main roads. Then we have the specific service roads, where they're also not allowed to the general traffic, but it is allowed to some selected motor vehicles and cyclists. And then we have the contraflow cycling, where the street is unidirectional, but for cyclists is bidirectional. So the previous ones are the different infrastructure types, but we have to extract them in a standardized format from OpenStreetMaps. And then here are the different tags that we use from OpenStreetMaps in order to extract every different type. Here you have the tags for cycle track, cycle and pedestrian track, and all the different infrastructure types that we described. And here are the other ones for specific service roads. We have also the explanation of the symbols. I won't get into very much detail, but if anyone wants, we can discuss this bilaterally after the presentation, why we use these tags and why it is based on the OSM guidelines. Just a short example in order to be more explainable. For the cycle tracks, here we see the tags that we have from OpenStreetMaps. You can see that the highway tag is path, then we have the bicycle that is yes, and then the bicycle that is designated and the segregated is tagged as yes. So this is tagged as a cycle track right now. And all the previous different types that we can extract, it is based on the OSM. All the tags that I described are an updated version of the cycle infrastructure tracker that we have developed from the European Cyclists Federation. This is an updated version. Currently on our website, it's the previous version, but in the coming months, we will also update it with these new tags. And also it has some percentages of availability for quality parameters in the website. Okay, that's the part of the OpenStreetMap extraction. But right now we have also to extract from the official datasets, the cycling infrastructure. So what we did, we have to do an extensive research of official datasets of cycle infrastructure datasets across the EU member states. And I'm speaking only for EU member states because it was a funded project from DG Move. It is called Cycling Counts. And for this project, we have identified, yes, indeed, 116 official datasets, cycling infrastructure datasets. From all of these, we further analyzed 48 of them because they had the indicator of the cycling infrastructure type and also some further quality parameters included, like surface type, surface quality, width, directionality, etc. So, which are these different official datasets that we identified and we further analyzed? Here is the whole table from it, that all the different datasets that we identified. If you know anyone else, any other dataset that is worth analyzing, that can include infrastructure type and quality parameters, feel free to share with us. And also we have the official dataset. In order to extract them, we have to do a very detailed review of the documentation of every different cycle infrastructure dataset, which is a difficult work to do, to be honest. Then we have to do some desk research in order to see, because we have also the problem of conceptualization. We may say that in one country, this is a cycle track, but in another country, they say again that this is a cycle track, but it's not the same. This is a very wide problem that we have seen. And also we have to consult with the dataset responsible people in order to understand every different type. So through this whole analysis, we were able to accurate mapping the different infrastructure types that we described before from the official dataset. And just to make it a bit more explainable, for instance, in the Netherlands dataset, the cycle tracks and cycle and pedestrian tracks were combined. So we have to combine also the OSM extraction to get it together in order to be able to compare them. And now we're going to the phase of the comparison, where currently, as you understand, after getting all these datasets, we have a dataset from the official resource and we have the corresponding dataset from the OpenStreetMap extraction. So we take these two networks and we try to combine them. So the next step is the comparison. Here is an example of the Austria network. Here is the Austria OSM network. It is the red line. It is not very clear, I think, yeah. But we also have the Austria official network. And we compare these different infrastructure types. We were very lucky that for Austria it was a very detailed dataset, but this is not the common case. We had a lot of different infrastructure types. For other datasets, we may only have cycle tracks. For instance, Netherlands, it only had cycle tracks and cycle and pedestrian tracks, and then this was combined also. It's not, they didn't have any other infrastructure type. So we are moving forward to the comparison. We have two networks and we have to compare. What is the methodology that we used in order to compare these two networks? The first part is to project both datasets in the coordinate system of the area of the analysis. So if we have to compare the Austria networks, we have to project it to this coordinate system. Then we created in every different network, the OSM network and the official network, a 10-meter buffer zone in order to identify, after the special overlays between the networks, to identify which network is the OSM network that is not in the official dataset, and also the official network that is not in the OSM dataset. And this is an automated creation through coding after creating all these overlays. But we don't stop there. We also do a correction of these previous networks regarding the angle intersection. I will describe these two parts a bit more further in the next slides. And then we have added also a link of the Google Street View in order to do some dirty view checks in order to have a better understanding of these datasets. Here are the 10-meter buffer zone that I described before. This one is for the OSM network, and this one is for the official network. So you can see here in the official network, we can see the parts that are in OSM but not in the official networks. And the same from the other side for the official network from the OSM buffer zone. But we also do the angle check that I described you. By just having the buffer zone, it is good to see some parts of the network that are not inside there, but you can see here a little tiny small segment that will fall under the buffer zone of the official network, but it's not the same network as the OSM network. So we have to do a check there. And we say that if the angle of the intersection is more than 40 degrees, we discard this one, and it's not part of the buffer zone of the other network. So through these checks, we have identified two different, in an automated way, two different GPKG files. The OSM network that is not on the official network, and also the official network that it's not on the OSM. And these two types of GPKG files, we have it for all of these datasets. And every GPKG file has the infrastructure type in a standardized format with all the different infrastructure types that we described before. And we also have the information, if it was available, especially for the official networks, for the surface type, surface quality, the lighting information, the width, and the directionality. How can we use these two GPKG files? The first one, we can use it to complement the OSM database by identifying what we found in the official networks, that it wasn't on the OSM, and then we can also find some incorrect information through the official dataset that it wasn't on the OSM. Sorry, for the OSM that it wasn't on the official dataset. The next steps for us is to share all these GPKG files with the OSM community, and because we want to give back to the OSM community, because we used and we found that this is a very detailed dataset there. Apart from the comparison files, I also told you before that this was a funded project and it's called Cycle Counts. We were able to identify through this comparison which dataset was more complete in every different area. So we extracted the infrastructure type that was more complete for every different dataset, either from the OSM dataset or from the official dataset. In order to do that, we have to do some combinations because there weren't a lot of information in all of these datasets. So cycle tracks, we say that these cycle tracks and cycle and pedestrian tracks. Cycle lane is cycle lanes together with bus and cycle lanes. And then we have the cycling-friendly mixed traffic roads, which is cycle streets, 30-kilometer roads, and specific service roads. This is a work that has never been done before. It's for all the EU member states. And also we have the contraflow cycling. The preliminary results of all these analyses that we found that there is a strong fragmentation of cycle infrastructure data at national, regional, and local level. And there is a great variation in the infrastructure type availability and the quality parameters availability. So there is an urgent need for standardization data, and OSM can play a significant role there. Just to give a thumbs up, in all the workshops that we have participated with the stakeholders and the dataset responsible people, OSM was identified as a very significant database in order to achieve that, to have a standardized format. Before going on to the Eurovelo use case, I just wanted to say that through all this comparison, we're going to share the results, but this was a comparison for the cycle infrastructure dataset. I think that we can go a bit further and use it also for other networks. Again, the Eurovelo network is a cycle network, but has also part of the roads that are the main roads, which is with motor traffic. So this is the European cycle route network, and we have done the same analysis also for this network. What is the case there? We have the OpenStreetMap extraction, but there are also 26 official national Eurovelo coordinator centers where they provide the official dataset to the Eurovelo team. So we had, again, for 26 countries, the different dataset, OSM dataset, official dataset. So we can do the same comparison there. Here is the comparison, again for Austria OSM network and Austria official network. And through this comparison, we can provide the same GPKG files. The GPKG file that has the official network that is not on the OSM, and also the OSM network that is not in the official network, in order to complement and find incorrect information. And what are the next steps of this work that have been done? We want to identify more official datasets. So I showed you the table, and we can discuss if you have any other cycle infrastructure dataset that can be compared and has a lot of information. We want to extend this comparison analysis to the quality parameters. Right now, we described about the standardization of cycle infrastructure, but we also have the quality parameters, which is a bit more tricky in order to find the standardized way to compare the surface type, the surface quality. Because from every different dataset, they may refer to something else. So, and then the final step is to expand the analysis to different cycle infrastructure, different types, apart from the infrastructure of cycle network. This is also the use case of Eurovelo, and I will be happy to hear if you could use it in another way. And this is my presentation. I only have 2 questions for you. If you can think any other similar methodology in order to apply it in a different network. And the most important one is, what is the most proper way to share with the OSM community these GPKG files? Because I think that can be a very added value, especially for the cycle network and the information inside OSM. That's it. Thank you.
So I'm part of Opus Belgium, and built a tool a few years ago, a road completion project, and the idea was to download all the official dataset for the road networks for Belgium, or we have 3 in Belgium, but also I think we have Netherlands and Luxembourg, and once a month it downloads the dataset of all of those 3 countries, compare with OSM, generate just like we did, we make 2 buffers, so the process is very similar. Then we generate what's missing in OSM, what's missing of what's wrong in the official dataset. We send the potential issue back to the official source, at least for Belgium. And for OSM, we push the change to Macrolet. So the community in Belgium can see the difference and try to map as easy as possible the change. I'll definitely have a look to Brussels and Mons that you're using in Belgium, because I think we could add those 2 datasets in our tool to see maybe work together to improve that, at least for Belgium.
Yeah, for sure. So this is not an exact question, it's about to discuss a bit more and to see the methodology behind. Yeah, for sure. For sure. We can do that. Yep.
Martin from Cyclists. So we worked extensively with Transport for London, who generated a very large data set of every piece of cycle infrastructure in London, with 2 photographs of each, very detailed, and it'd be interesting to apply this methodology to that, because they were keen to get that into OpenStreetMap. We developed a similar methodology involving buffer zones and so on. I suppose, so I was interested in your point about, how the OSM has a role, you put in terms of kind of being maybe some way for official organisations to maybe in the future capture. I wonder what your thoughts are as to whether OSM needs to do more to really document better and standardise the way it does things. I noticed, for example, your chart of the way the tag combinations, but for example, the German method of shared use, for example, wasn't included on that. And, this kind of variations, looking at the wiki is very difficult. We've spent 10 years trying to interpret this stuff, and you still end up with difficulty. So I wonder kind of in terms of trying to get official bodies to buy into OSM more, whether you experience any sort of discussions about the need for OSM to improve itself, the way that it describes this infrastructure.
So the question is what the OSM community can do in order to have more specific guidelines in order to tag the different cycle infrastructure parts. Am I?
Yeah, for different types of infrastructure, yeah.
Yeah.
And as a way to bring in, official bodies to consider it as a way to actually...
Yeah, that's a hard question. This is for all the OSM community to be done. But from my perspective, from the cycle infrastructure part, I think that maybe a bit more of a combination, like the one that we did. Not to have a lot of variation, at least in the very start of the whole analysis and the next steps that we can do as the cycle community and the OSM community. So I think that the combination of cycle tracks and cycle and pedestrian tracks together in a very specific guideline, then to have cycle lane and bus and cycle lane together, and then the mixed traffic that refers to the cycle infrastructure. These are the guidelines, and these are the guidelines based on the whole analysis that we did not only for OSM, but also for the official datasets, that they had the same problem, because there is a problem not only on the guidelines, but also on the conceptualization, the different conceptualization that may happen in every different country. When you refer as a German people to a cycle track, maybe it's not the same for a Bulgaria people. They may refer to something very, this is very difficult, that was very difficult to understand. You have to consult with different dataset stakeholders and then again fix the puzzle of all of it together in order. This is our approach. This is the combination that we have done in order to make things more easy, but the results will be validated in the future to see if this is the best approach. Yeah.
Yeah, I mean, just as quick feedback, I think the combination of dedicated cycle tracks and mixed use, certainly in the UK perspective, is very problematic because that mixing is very different to, say, the Dutch approach. The Dutch approach, I mean, I can see why they mix them, because essentially cycle tracks in the Netherlands are of they're good quality, but also they're, between areas where there's no pedestrian pavement next to it. A cycle track is essentially a cycle facility on which pedestrians are allowed to use it, whereas in the UK, shared use is really pedestrian infrastructure which cyclists are allowed to use it. So although both end up with bicycle equals yes and foot equals yes and bicycle equals yes, they're fundamentally very different things by the standard of design. So I think some care would need to be done to sort of make sure that you don't end up kind of lumping essentially very good infrastructure with the kind of Dutch type with the kind of British shared use rubbish infrastructure, which appears to be the same thing in OSM, but actually is completely different.
Yeah, I totally agree. And this study was only for the EU member states, so we didn't have the chance to see the official dataset of. But yeah, I will keep this feedback and I'll try to incorporate that. Yeah.
Thanks for the talk. I was wondering how you handle cases where one dataset will map the cycleway or something along the road center line, and the dataset you're comparing to might have a separate geometry. So, like, say in the case of like a one-directional cycle track on each side of the road in OSM, and then like in a reference dataset, you just have it as an attribute on one line. When you like do the buffer approach, how do you join that together to really make sense of it?
So the question is that when we have the different geometries, when we have two different, and it's the central line, how we approach that the problem. The problem, it was mainly done by the meters of the buffer zone. So if you have a 10-meter buffer zone, you will include both of them. So you will say that these are together and it's the same cycle infrastructure. Is this your question? So we had to play a bit more with the meters of the buffer zone. So if you have a center line, like in the OSM tagging, that you say that this is cycle right, cycleway right and left, then when you have the buffer zone, they're included in this buffer zone. So that was the approach. And then the problem was in the official networks that we have to do some merging there in order to see exactly. We will have some duplicates in order to account the same length in these two. Is it clear?
Yeah, I guess like there's also cases in near complex junctions where like the OSM model, it might look like a cycleway sort of appears and disappears because the legitimately rejoins the road or something like that. And like in an official data set, it might be simplified to just say like there's something the whole way through? Like, do you just have cases where even in that buffer zone, like it looks like the OSM is sort of available for part of only for like part of the official line?
The only approach that we did was this one for the comparison. We created the buffer zone, so we didn't get in a very detailed way of that, because the whole aspect of the project was to identify the project itself. It wasn't about the comparison. It was about to identify which infrastructure type was better in every area. So to compare the cycle tracks with the cycle tracks, the cycle and pedestrian tracks with the cycle and pedestrian tracks. So with these tiny details, we didn't have a problem to accurately say that, okay, cycle tracks are better. But again, this approach for the comparison files, we may have some inaccuracies, but we will try to fix that. Yeah. If this is clear for you.
I see, thanks.
Thank you.
Yeah, just quickly, the discussion about the Eurovelo routes and the organisations maintaining official data sets for the Eurovelo routes made me think about the keynote that we had yesterday from the National Trust, where that's a large organisation that decided their hiking and walking routes, the official data is going to be stored in OpenStreetMap. Do you see a future for the Eurovelo organisations where the official data is the OpenStreetMap data?
That's a difficult question, because we have done, at least for cycling, we haven't done this for the other networks. We have seen that the current quality of the OpenStreetMap is not the same level as the official dataset that we get from the official correspondence. So there will be a bit more of work to do in order to have this as an official. I would love to have that, but the Eurovelo team needs some bit more detail, because it has to do also with some specific, and they don't want to have some missing segments. So we will see.
Just one more thing to that. The source trans, as well as the equivalent in the UK, has actually just gone through a process with OSM to say, this is what we think our routes are, this is what you think our routes are, here are the differences. Please tell us who the right.
That's also the general discussion of the project, that we have to think about different countries and different conceptualizations, and to say that you will be all happy with the results. I don't know if there is any.
It's the general rule. These routes are set by the national body.
Sorry, can you repeat? I didn't hear.
Is the general rule that these routes are set by the national body, so that a Eurovelo route in the UK will follow the Swiss-Trans Walk-Wheel Cycle Trust route? That's useful to an OSM member who says, well, I know that National Cycle Network 1 has diverted here. Should I also divert the Eurovelo travel route as well?
Yes, this is a more specific question for the Eurovelo team. I just wanted to present a different type of comparison for that. We can stay in touch for that question in order to clarify it. Yeah.
Okay, we're pretty sure out of time now. So thanks to Christos there. Thank you very much.